Okay, welcome back. Now we're going to do a demonstration about specific heat. I've written the specific heat of lead here, 0.030 calories per gram Celsius. The specific heat of water, 1 calorie per gram Celsius. Aluminum, 0.215 calories per gram Celsius. So what I'm going to do, the concept, is that I'm going to take some lead shots. I'm going to put it in a container, right? And then I'm going to warm it up with some water. Okay, so I have some water, but I don't really need to know how much water is there. I'm going to warm up the water to like maybe boiling temperature, right? Boiling. And I'm going to use that as a way to warm up the lead shot. So I have here lead. Okay. Lead. We call them lead shots or lead pellets, you can call them. And then I'm going to find out the initial temperature of the lead. T initial. I'm going to put a thermometer in there, right? Then I'm going to prepare my calorimeter. A calorimeter is a device that kind of creates an air gap between the outer cup and the inner cup, right? So then I have an inner cup here. Then I'm going to have some water here in an aluminum cup. Okay. So I'm going to put some water there. I'm going to measure the initial temperature of the water, T initial, right? And then after this has warmed, so the initial temperature of the metal, we expect it to be somewhere in the 90s, right? Let's say 90 to 100. It could be even below 90, but it's going to be warm. The initial temperature of the water is probably going to be around 20 to 25 Celsius, maybe 20 to 25 Celsius. Then I'm going to take that lead shot and put it into the water, and then the water's temperature is going to go up slightly, but the lead shot is going to go down a lot more because metals change their temperature a lot more than water does. Water retains its temperature because it has a very high specific heat, right? So after I put the lead shot over there, I close the lid, and then I put the thermometer in the mixture, and then I find out the final temperature of the mixture, T final. Using that final temperature of the mixture, I can do a calculation to find out what the specific heat of that metal is, and then I can compare it to 0.030, right? Now, I'm going to do the calculation twice. One time, I'm going to assume that the cup itself, the aluminum cup, doesn't participate in the heat exchange. So I'm going to ignore the cup, and I'm just going to say the heat given off by the metal goes directly into the water without it going into the cup. So let's assume what kind of result, let's calculate what kind of result we get from that. Then I'm going to do a recalculation, and I'm going to find out, well, what if some of the heat goes into the cup, into the aluminum cup, and the cup also warms up. And then I'm going to do a calculation based on that and see which one gives me a better result, okay? So I'm going to show you the equipment now. Here's my calorimeter here, okay? It has the inner cup in there. This is a foam. We can use that to put it around the cup and to create an insulation. This is the inner cup there. And then I have 60.2 grams is the mass of my aluminum cup, and that's going to be the inner cup, 60.1, 60.2, around that area. Then I'm going to fill it up with some water, and then I'm going to measure the mass of that water and its temperature. Now here I have the boiler going, okay? You can see that it's really, really hot now. It's moist here. And then in here is the lead shots. Right? So then I'm going to measure the temperature of the lead. Then I'm going to put it into that cup and then close the lid on it. So let's do the measurements and see what we get here. Okay, now you can see that I have the inner cup. I put some water there, and then its mass is 262.5 grams. So we'll record that. Okay, then I have the thermometer here. I'm going to put the thermometer in the water. All right, find out the initial temperature of the water. 23.9. Okay, we've got the so the final temperature that the thermometer reaches and it stabilizes, 23.5 Celsius is the initial temperature of the water and the cup itself also, 23.5. So let's record those. Okay, now I'm going to take my cup and then I'm going to put it in my calorimeter. So I put this here, right, to rest it on, and then I put my inner cup in there. Okay, so I'm going to wait a little bit, and then after it's gotten really hot, I'm going to go over here, record the temperature, I have 97.3, 97.4, and probably I'll take the metal. Okay, 97.5. So at this point, let's take the thermometer out, take the lead shots, okay, and then just hold them like this, and then quickly put them into the water, okay, and then close the lid like this. So then use this to stir, go up like this, and then I can monitor the temperature that the mixture is reaching. 29.6, keep stirring it slightly, keep stirring it lightly like this, put the thermometer through the middle. 29.6 Celsius is my final temperature of the mixture. If I wait a little bit longer, okay, 29.7. Okay, from there we can now do the calculation. So my final temperature was 29.7 Celsius, right? And then my initial temperature of the metal was 97.5. 97.5 Celsius. Now there is lots of sources of error here, because when I'm removing this lead and then putting it in here, it's losing some heat. And then the calorimeter itself is not a perfect thermos, so some of the heat given off by the lead will not only go into the water, and some of it will not only go into the aluminum, but some of it will be lost through this air gap out to the outside. So there's those sources of error, and then measurement errors, and so all of those will play a role in causing some error. I'm going to put another 200, right? So that's already 400. Then I put here, this one is a 100 grams, so that's 500. Then I'm going to add these, so I'm already have 500 on the opposite end. Then I'm going to move these over until I balance the double beam balance. Okay, so you can see basically this one is on 200. So this one was 500, 200, and then now I'm going to balance this one here until this is in the middle. Okay, so basically it's about exactly, this is on 0, so it actually came out to be pretty even. Right, so this is going to be 200, 200, 400, 500, another 200, that's going to be 700 grams. Altogether, everything is 700 grams. Now we can do the calculations. Total mass with the metal in there is 700 grams. Okay? Okay, now let's write down the calculations. So we're going to say the heat lost by the metal is equal to the heat gained by the water. Right? So heat lost by the metal. So I'm assuming the first calculation that the metal loses heat directly to the water and not much of it goes to the cup. So the heat lost by the metal is going to be the mass of the metal, the specific heat of the metal, and then change in temperature of the metal. Right? And then this is going to be the absolute value of the heat lost by the metal. So I'm going to write it so that it comes out positive. And then I'm going to take the absolute value of the heat gained by the water, but the heat gained by the water is already positive. The heat lost by the metal is negative, so if you take the absolute value, you get positive. So you're setting two positive numbers equal to each other. So the mass of the water, specific heat of the water, change in temperature of the water. Okay, so mass of the metal is going to be what? Well, we're going to have to take 700, subtract 262.5 from there, right? That's going to tell you how much metal I had. The mass of the metal is 437.5. The specific heat of the metal, I don't know. I'm using this as an experimental way of calculating what the specific heat of the metal is, right? Then what's the change in temperature of the metal? Well, it went from 97.5, which was its initial temperature, 97.5. Then it went all the way down to 29.7. 29.7. Then the mass of the water is going to be what? 262.5 minus 60.2. So subtract 60.2, because that was just the mass of the cup, right? So that's going to be 202.3, right? 5 minus 2 is 3, and then 2, so 202.3. So that's going to be the mass of the water. The specific heat of the water is 1 calorie per gram Celsius. The change in temperature of the water, well, the final temperature was 29.7. The initial temperature of the water, 23.5. Okay, so this one we can just calculate that. We can metal, right? So therefore, the experimental specific heat of the metal is this number divided by this, right? Specific heat of the metal, 1254.26 divided by 29,662.5. So you get here 0.04228 calories per gram Celsius. So what was the actual specific heat of the metal for lead? The specific heat of the lead is going to be 0.03 calories per gram Celsius. So you can see my result is not really that good percentage-wise. These are really small numbers, so I'm okay with that, but percentage-wise, this is actually a pretty large error. So all of the sources of error that I mentioned earlier, as in losing heat, and even when I'm measuring the initial temperature of the metal, the 97.5 is not an exact number because it depends where the thermometer is touching, right? So even that number is not an exact number, but I'm still in the ballpark of the answer. So how could I incorporate the cup? What's happening to the cup here? Is that going to help my result, or is that going to make my result worse? Well, in reality, the aluminum cup is also gaining heat. So we should actually include the mass of the cup in there, right? So then how is that going to change things? The mass of the cup is 60.2 grams. So I should add on top of this, I should add the mass of the cup plus the specific heat of the cup times the change in temperature of the cup, right? Multiply them all. So the mass of the cup is going to be 60.2. The specific heat of the cup, which is aluminum, is 0.215. And then the change in temperature, 29.7 minus 23.5. Right? So then, what's that number come out to be? 499. It changes a little bit, but not that much. So we have 0.04 instead of 228. I have here 499. We can say this is the better way of doing it because we're incorporating the change in temperature of the aluminum cup, but the result is actually a little bit worse because we're more off from from what we expect to get, right? So you can see from this lab experiment that is meant to help you understand the concept of heat gain, heat loss, the concept of specific heat, and how to measure this experimentally, right? Heating up a metal, putting it in water, and then finding out the temperature. Thank you very much.